Hello everybody, welcome back to another edition of the Modicon M221. I'm your host, Leandro Mala, and in this video what we're going to see is the PWM output that we have for the PID in the software. So let's go to the presentation. So in the previous video we have seen the different actions that we may have on the output, the manual output that we can assign, the limitations, but I have left for this video how we can work with the PWM. So let's go to the next slide. So we have already seen this, okay? So we already know, just put the pen. We already know all this part, okay? Now what I want to focus is in this. So in order to have a PWM output, okay, doesn't mean a physical output, a percentage Q. It can also be used a percentage M to use a memory bit, as I'm using here. Okay, so we need to authorize this, and then we should be able to access to this information. The information that we need is the period, to find the period of the signal, okay, to assign this signal to a output or a memory bit. And then the PWM will work with the duty cycle that I want for the PWM. So now I already mentioned that it can be percentage M or percentage Q. Now there are a few things that we need to configure, and one important thing is the definition of the cycle time that we have for the mask. If we don't configure this, I found out that it doesn't work as suspected. So we must configure the cycle time of the mast that we're gonna be called. So I'm going into details, but I want to show you this. So in order to configure the period, what we need to do is to go to the programming tab, okay, go task, select master task, which is my case where I'm calling the PID, and then define the period that you want. Otherwise, I don't think it's going to work as expected. If you select normal, no. Select period and define the period you want. Then that will be much easier to calculate everything. Then the other thing that we need to do is to define the period for the task that you want. That period, okay, can be a percentage NWU or a constant or a fixed value. It doesn't matter. One thing that I know 100% sure based on what I have tested is the limit. In the help it says from 1 to 500, but I managed to use more. So stay with help, but I was able to do more. And the period is defined for 0.1. So if I use 500, it's going to be 50.0 seconds. Okay. Here is something important: the precision with the period. Okay, that we have defined in here. This one, and the scan period. And this scan period, I found out that this period that you configure on the task. So imagine that you have a scan period 20 milliseconds and the period is 200 milliseconds, okay? Then you should be able to find from 0 to 100, which is the duty cycle, more different scales or more precision in order to define the output, okay? You can see over here, if it's 20 milliseconds, you have more precision, right? That if you have the scan period in 50 milliseconds, okay? You have from 0 to 100, you have 0, 25, 50, 75, and 100. And here you have from 10, 0%, 10%, 20, 30, 40, and so on. So what we're going to do is to test this part. So for this particular case, I want to test this not using the PID block, using the PID, but not the logic for the PID. I am going to work only with the manual mode, so we can easily see this this behavior. So we're going to configure the manual mode that was already configured on the previous video. Okay, it's just assigned a variable for the block. So let me just show you. So here, output, no, this one, yes, this one, manual mode, the bit and the output value that we want. So this part is already covered. Configure the PWM output and assign. Okay, this part, it was already covered, but I didn't show you. I authorize this and define a variable for the period and a variable to see the pulses. Okay, ready, done. It was faster. Configure a period time for the mast, and I have already done that. Okay, so cancel this part. If you go code programming task, you have master task, and here you can define the period. In my case is 100 milliseconds. Okay, so I'm going to check this, download the application and enable the PID and check the output. As an option, I'll make the trace. So I already pre-configure all those parts, as you can see here in this table. So now I'm going to download this and play with it. So here, download. Okay, yeah. Okay, so it's download, play. Okay, so now let's activate the trace. So I have this trace, which should be the output that I want. Let's start this. So should be something from here. Ah, it's already one. So let's see. It's in automatic. No, let's do manual, and I'm going to use the output 0. Okay, bit period is gonna be 100. There's gonna be every 10 seconds. Okay, and now I'm going to reset this, and I'm going to start again. So right now I'm going to start from 0. Okay, the manual mode is already activated. What I'm going to do is to assign the 50% of the duty cycle. Probably need to reduce this part like this. So it's in 0, it's over there. So what I can do is to define the 50%. The 50% will be the 50% of the minimum and max value that I have. The minimum value is going to be 0 and the max value is going to be 10,000. So the 50% is going to be 5,000 for the output. So manual output 5,000. So if everything goes well, what we need to do, I'm going to let this be for a little bit. We should be able to see a cycle, okay, of 50%, as you can see over here. Probably not as good as mine, but there is 50%. What we can do is to extend the period, so we have a further definition. Okay, let's see how long does it takes. But as you can see here, I got 0.45 seconds, and here I have 0.55. So from here to here I have 10 seconds, which is what I have already pre-configured for the period. Okay, and now if I multiply by 10 this, okay, so you can, the idea is to show you much better the behavior. Probably I should have just a little bit more shorter time. But as you can see here, the period allows you to have a higher value. Let's try to, I want this to make it faster. So I'm going to use 20. Okay, so it's going to be the double of this. The idea is to show you the different duty cycles, but I believe here you can see how it works. Even if I use the 50%, you can see that 50% of the time of the period, okay, is in true, and the other one is going to be in false, which is fine. And then you should be able to play with the different value that you have for the output, to play with the duty cycle. So as soon as it finishes this one, the idea is to play with the different duty cycles that we can assign, just to show you that it works. Okay, but I believe you already saw what I meant. In this one is 200, my bad. So we should be able to see the double of this. Okay, just wait for it. Well, it doesn't show that much, but okay, it's gonna be a little bit more bigger than this one. Okay, so I have from 0, 3, 0, 4, 0, 5, it's gonna be 20 seconds, 25. Okay, so this is how it works for the 20 seconds and 50%. So now we can play with this and define, okay, I don't want the 50%, I want the 20% or the 25%. So it's going to be 2,500. So in the next time, you should be able to see a lower part in 1 and the other part in 0. So in this one, let's take a look. Let's just try to finish the cycle so we can really see this behavior. But I believe you already got the idea. It's very simple. To just define the output, define the period, define the task mask on the task, the cycle that you're gonna have, and then you should be able to see this in a much better way. Okay, so you can see in there that after 20 seconds, I have the 25% of the cycle in true and the other one in 0, and the other way would be when I have 7,500, it's gonna be most of the time in 1 and the other one in 0. So probably it's going to have the effect in the next cycle rather than this one, because it has already started. So after 20 seconds, we should be able to see it change. Okay, let's wait for it. So it's counting. Okay, so this one is going to be more time in true than in false. Okay. There we go. So this is how it works. I just want to show you without having a real plan, so you really see and understand how this works. Okay, so if I'm wrong, this is it for the PID. Download the application, enable the manual mode, change response to the output. We already seen that, and create the trace with the output. We already covered this part. As you can see, it's very simple once you understand. The idea is to understand what we're doing, and then we should be able to easily apply this. So this is it for the PID PWM output that we have. Thank you very much for watching this video, and I see you on the next one.